Okay.
Okay.
So talking in plain terms, this transmission could either any type of transmission could either be of the form of either serial in nature, or it could be uh, in parallel. Okay, so in serial communication, there is a transmitter and there is a receiver, and the information is transmitted using one channel. There is only one channel between transmitter and receiver, so that is utilized in transmitting the information. So, and since the information is in forms of bits 0 and 1, so serially they are transmitted. Okay, while in parallel communication, uh, the bits are transmitted simultaneously. So there are multiple channels connecting the transmitter and receiver, and those bits are carried on those channels, and they are transmitted to the receiver end, and it is received by the receiver. So if I talk about the pros and cons of the two ways of communication between two devices, as you could easily see that serial communication is slower. It has to be slower because a packet of data that need to be transmitted from transmitter to receiver has to be transmitted serially, one by one. So one by one data is transmitted. So that means the transmission process will take longer time. While the advantage is that since there is only one channel connecting the transmitter and receiver, so it is cost effective. Okay, and almost most of the communication throughout the world is serial communication. Okay, then the another way of communication is your parallel, and you could see that since the data is transmitted parallelly, so the communication process is fast. Okay, but definitely it is at the cost of it comes at a cost, and that is you have to pay more for it, so it is costly. Okay, so this is a basic difference between serial and parallel communication. Um, there is option to transmit data parallelly in 8051. You know that we have parallel, we have ports in 8051, and through those ports, each port has got 8 bits, and you can communicate in parallel fashion also in 8051. Okay, but as I told you, that definitely that you require these mediums to connect the transmitter and receiver. Okay, and there is no special uh, peripheral for parallel processing of data and transmission of data in 8051, but we do have a special peripheral for serial communication. Okay, so we will be talking about that in a short while from now. uh, Now, within serial communication, we have three ways of communication possible. One is called simplex communication, which is shown here. Okay, simplex communication is where there is a transmitter and there is a receiver. Okay, and transmitter, it this system, it always transmit data, and this system always receive data. Okay, it is not vice versa. And example of this type of communication is the common example could be your printer. So you always give from CPU to printer. Okay, so you always give information to the printer. Okay, there might be possible that we nowadays might be there may be printer which you can communicate back to CPU also, but the normal printer works in this way only. Simplex communication is there. Then another one is called half duplex. Half duplex. Okay. So here we have transmitter and receiver here also, and transmitter and receiver here also at both ends. And there is only one channel. Okay. So this end could act as a transmitter or as a receiver. It cannot act as both simultaneously. Similarly, this end also can act as a receiver or a transmitter, cannot act as both simultaneously. So that means you can transmit data and it will be received here, or you can receive data which can is transmitted from here. Okay, this is called half duplex mode of serial communication. Then another method is called the full duplex method of serial communication. And in this transmission and receive and receiver, we have transmitter receiver here also, and it is possible to transmit and receive data simultaneously. Okay, so this feature is available in 8051 with the help of uh, uh, two pins that are available in 8051. Okay, and those pins, one is RxD pin and other one is the TXD pin. The TXD pin is on port 3, and zeroth pin P3.0 is the TXD pin, and P3.1 is the RxD pin of 8051. So full duplex operation is possible. Okay. Okay. Then one more term I would like to discuss, rather two, three more terms uh, associated with communications, rather serial communication. So one is your asynchronous communication. Asynchronous communication. Asynchronous serial communication. Uh, so between transmitter and receiver, asynchronous serial communication means that uh, we have got a separate clock for transmitter and separate clock for receiver, although they operate at same frequency. Please, there's one common misconception among students that asynchronous serial communication involves wherein transmitter and receiver operate at same different frequencies, so it is called asynchronous. No, it is not the case. They both operate at same frequency, but they operate from different sources of clocks. Okay, so that is asynchronous serial communication. And the second one is the synchronous communication. Here, there is a common clock. The clock is common. Okay, so you could see that both asynchronous and synchronous mode of communication is possible in 8051 also. Okay, so there is a common clock which connects both of the transmitter and receiver, and there is a uh, communication between the receiver and the transmitter. Okay, in 8051. But you could see here that if we are using this synchronous communication method, then definitely uh, full duplex is not possible in synchronous mode in 8051. Okay, and there is one more term which is called, very important term, baud rate. So baud rate refers to uh, actually the rate at which the information is transmitted serially. The rate at which the information is transmitted serially between receiver and transmitter. So that is referred to the baud rate, and it is quite important uh, 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 because one has to keep the baud rate for the transmitter and the receiver same, so that data is not lost, and unwanted data is not generated. Okay, so it is important term regard to serial communication. Okay, more about it, how it is calculated and what exactly how we use it in 8051. I will come to that when I will calculate the baud rate in 8051. Okay, so this was some of the basic of communication, and let me now come to serial communication in 8051. Okay, so we have this microcontroller 8051. It has got a processor. Okay, and there are two separate SFRs called SBUF. Okay, so this SBUF is an SFR, special function register, and it actually stores the data that needs to be transmitted. Okay, and it also receives the data that is transmitted from some other uh, from origin, and when it is received by the microcontroller 8051. Okay, so there are two separate SBUFs in 8051, two separate registers, but their name is same for both the registers. Okay, and although it looks like that if name is same, then they might create a confusion, and there will be a confusion for the microcontroller to understand whether this SBUF is for transmitting data or for receiving data. Uh, it is not the case, because the instruction itself will indicate whether this SBUF is used for transmission, or whether it is used for receiving the data. Okay, and I will, when I write the instruction, you will know. Okay, yeah, it's just think of this instruction: move a uh, a comma SBUF, and another instruction is move SBUF comma a. So what is the difference between the two instruction? In one instruction, the content of SBUF is copied in a. Okay, that means it is for receiving purpose. While in the second instruction, the content of SBUF is copied. Sorry, the content of A is copied to SBUF. That means it is for transmission. I hope you can appreciate the difference between the two instructions. Okay, so I will first try to explain you in very simple terms how serial communication happens in 8051. Okay, so please listen to it carefully. So what happens? Uh, Say you are interested in transmitting some data. Say for example, you have got 25H. This is a data, and if you write it in a binary form, it is how much? 0010 and 0101, I think, isn't it? This is 2 and this is 5. So you are interested in transmitting this data. So what is done in the instruction, in the code, this data is copied in SBUF. Okay, it is not that the processor is involved in transmitting the data. Rather, these two SFRs, okay, SBUF, they store the data, and uh, and uh, and this data is then serially transmitted to some other location with the help of TXD and RXD. For transmission, it is TXD, and for receiving, it is RXD. Okay, so it is transmitted through this line. And while the data is being transmitted, the processor is free to do some other operation. Okay, so what happens in the instruction? You write the data that needs to be transmitted in SBUF. This is your say this is your SBUF register, and you write the data here. Say I'm writing it. It is uh, uh, 1 0 1 0 0 1 0 0. Okay, so this is your least significant bit, and this is your most significant bit, MSB and LSB. And let me tell you that uh, in transmission and even in receiving the data, the lowest significant bit is transmitted first. Okay, so this one will be transmitted first, and then this zero, and then this one, and then this zero again, and then this zero, and then one, and then zero zero. Okay, do you understand that? The least significant bit is transmitted first, and definitely it will be received by some receiver will be here. So this least significant will be received by the receiver first. Okay. Then similarly, when it is receiving the data, the microcontroller says the same data 25H is being transmitted. Similarly, the same thing happens. The this end also will have a microcontroller, some microcontroller which will be acting as a transmitter. So it will be sending the data. So definitely, it will be sending the data in this fashion, with the first data being the least significant bit. Okay, and it will be coming to the um, receiving pin of the 8051, which is acting as a receiver, and then it gets stored in the SBUF register. It gets stored in the SBUF register here. Okay, 0 1 0. Is it fine? Now, what are the various things that happen while the data is being transferred and the data is being received? Okay, say for example, you are interested in transmitting this data 25H, and you have written it into SBUF. Now SBUF is transmitting this data. Now you want to transmit another data, say 65H. You want to transmit 65H. What you will do? You will write 65H into SBUF again to transmit it. Okay, but the problem here is that it may be possible that the data which is being transmitted, which is 25H, has not been transferred completely yet. And if you write down this 65H again on SBUF, it might happen that you are overwriting on the SBUF register, and you are actually causing error. Okay, so that means there has to be some mechanism in which the processor should know that SBUF has transmitted the data completely. The set of data or 1 byte of data has been transmitted completely. Okay, so that is done with the help of TI bit. TI bit. So this is TI bit, which is a flag for serial communication. I think when I was talking about the various interrupts in 8051, I might have just slightly touched this topic, that we have two flags. for serial communication for causing an interrupt. One is the TI, okay, and the other one is your RI. Sometimes we write in capital, sometimes we write in small. So TI and RI are the two flags, and where they are present, they are actually present in the SCON SFR. SCON. SCON is an SFR. Okay, SCON is also an SFR. So I will be discussing about SCON. Right now, just remember that this TI and RI bits, they are in SCON SFR, SCON register. So what happens when all the data, this 25 it has been successfully transmitted from SBUF to this channel, then SBUF sends a message to the processor that one byte of data has been transmitted by setting this bit TI. TI gets automatically automatically set. So when TI gets automatically set, that will cause an interrupt in the 8051 processor. So it might have been doing some operation, the microcontroller, and when TI gets equal to 1, so interrupt happens and then it moves to the location vector. It is also an vector interrupt. So vector location, it moves to vector where the ISR has been written. And in that ISR, if you want to transmit some other data, so that is now copied to the SBUF. So move uh, SBUF comma SBUF comma A. So here whatever is in A, it gets again copied with SBUF. Now it is ready to be transmitted in the next few cycles of transmission. And one more important thing is that while it returns from ISR, so last instruction needs to be RETI. I told you that RETI instruction has to be there in ISR. So before writing this instruction, the programmer should also clear this TI, CLR TI bit. This has to be cleared by the programmer. So this is different from the other type of interrupts which we studied, like your timer interrupt or your hardware interrupts, wherein the flag register gets automatically cleared. Okay? Here in serial communication, when the interrupt happens because of TI or RI, then that needs to be cleared by the programmer. So you have to write an instruction in the ISR wherein you clear this TI. Okay. So if you do not write TI will be set any one, and when it moves back to the main program, again it will move to ISR because TI was set. Did you got the point? So this is important that TI needs to in the ISR itself. In the same way, uh, when data is being received by the when it is acting as a receiver, 8051. So SBUF, it is storing the bits in its registers one by one. So once all the data, 8 byte of data has been stored in SBUF, then it sends a signal, then it informs the processor by making RI bit equal to 1. So when RI become 1, that means 1 byte of data has completely been received by SBUF. Okay, now processor again moves to the SFR, then it uh, moves the information that has been received into SBUF into some other register for other purpose, whatever purpose it has been received. Okay. So is there any, could you understand the basic operation of the serial communication in 8051? Is there any doubt here? If there is no doubt, then I will move to the various modes of serial communication. So kindly let me know if there is any doubt till here. No doubt. I hope I am audible.
Yes, sir, you're audible.
Okay. So there is no doubt. So let us move to the important SFR of serial communication, which is SCON. It is an 8-bit register, and let me write down the various bits of SCON. Okay. The first two bits are SM0 and SM1. Then the next bit is SM2. The I'm writing from the higher side. Then we have REN. Then we have TB8. Then we have RB8. Then we have your TI, and the least significant bit is your RI. Okay. So now let us look into the various bits of SCON, and it is quite important to understand these so that you can write effective program in using serial communication in 8051. So I already explained about these two bits, RI and TI. RI and TI are basically two flag bits. They get set whenever TI gets set when a complete byte of data has been transmitted from SBUF register, and it gets sets, and it sends the signal to the processor, and the processor moves to the ISR. Similarly, when complete byte of data is received by the SBUF, it sends a signal by setting RI equal to 1, and the processor moves to the ISR. So I think these two bits are simple, and I hope you have understood this. Okay. I will come to these two bit after some time. Okay. After some time. Then this is REN bit. It is basically enable disable reception. Enable disable reception. So if you are interested in receiving the data, that means the microcontroller 8051 is, you want it to act as a receiver, then you have to make this bit 1. Oh, sorry. Okay. And you do not want the microcontroller to receive any data at RX D pin, so you have to keep it equal to 0. Okay. Now SM2, again SM2, I will come to it after a while. Before that, SM0 and SM1. So these are mode selection bits. Uh, so there are two bits, so four modes are possible. When both are 0, to mode 0. 0 1 means mode 1. Sorry, 1 0 means mode 2, and 1 1 means mode 3. So this is mode 0, mode 1, mode 2, and mode 3. Mode 0 is actually a shift register. shift register. Okay, and mode 1 is 8-bit UART, and mode 2 is 9-bit UART with one programmable bit, and mode 3 is 9-bit UART. Okay, and the baud rate in the four cases are: in mode 0, the baud rate is fixed. It is FOSC by 12. And in mode 1, it is variable when timer 1 is invoked. Okay, and in mode 2, it is again fixed. It is either FOSC by 64 or FOSC by 32. And in mode 3, it is again variable. Okay, so these are the four modes of serial communication of in 8051. By selecting 00, we select mode 0. Similarly, 01 mode 1 is selected, 10 mode 2 is selected, 11 mode 3 is selected. Now come to a bit description of what I have written here. Okay, so again I will come to mode 0 after some time. Let me start with mode 1. Mode 1, what it means? I've written here 8-bit UART. UART is basically a communication protocol. Okay, uh, and universal asynchronous receiver and transmitter, receiving and transmission. Okay, UART. Universal, it is called universal because it has been universally adopted in all types of communication. And what exactly it is? Actually, when there is a transmission and a receiving happening, and data is being transmitted from this end and being received here. Okay, so there need to be a protocol which would tell the receiver that a complete data has been received. Okay, say for example, in the previous case, I was talking about this transmitting 25. Okay, so 25 is being transmitted on this line and being received by the receiver. After some time, uh, say for example, 65 is also being transmitted. Okay, so uh, this receiver should know when to start uh, counting for the data that is being received and when to stop. Okay, say for example, let me take an 8-bit data, and then another 8-bit data. Okay, say for example, this is being received by R. Okay, uh, before this being sent, R was high. Say for example, this is the data. Okay, so by default, this pin, the receiver pin is high. Okay, so when this when if it is receiving 0, that means the data has started coming in. So that is okay. But when this last bit is 1, say, and earlier also it was 1 by the receiver. So how will it know that data has started coming and it has to store that data for some other operation? Okay. And again, when will it know that uh, a complete byte of data has been reached? Okay. So that information needs to be uh, known to both the transmitter and the receiver. Okay. So what happens in UART communication when 8 bits of data is being transmitted? There is a start bit and there is an end bit. There is a start bit. This is called start bit, and then there is an 8 bit end bit. Start bit is always 0 and end bit is always 1. Okay, please remember this. So that means now 10 bits of data are being transmitted. 10 bits of data. So whenever transmission will happen in mode 1, 8 bits will not transmit on the line, on the channel. Rather, 10 bits will be transmitted from the transmitter and it will be received by the receiver, in which the start bit will always be 0, which is not part of the 8-bit information that you are transmitting. 8-bit is something else. Say you this is your 8-bit. Okay, so that is different. But to convey the information to the receiver that now bits are coming, so this 0 is attached. Okay, and similarly at the end, this 1 is attached to this data, and it signals that operation is, yani one complete byte of information has been transmitted. Okay, so what is the significance of putting 0 here and what is the significance of putting 1 here? You see, I told you that by default uh, the receiving pin is at high at the receiver. Okay, so whenever first 0 comes, it tells the receiver that now the data will start coming. Okay, so this first bit is actually not stored by the receiver, rather it is discarded, and from next bits the data are stored. Okay, is it fine? So that is the concept. That means 10 bits of data are being communicated from the transmitter to the receiver. Similarly, let me talk about mode 2 and mode 3. In mode 2 and 3, 9 bits of data, 9 bit UART is transmitted. So why 9 bit? So apart from this 8 bit and 0 and 1, there is another programmable bit. So this is your 0 bits, and then we have 8 bits of data, and then there is a programmable bit, and then this is 1. This programmable bit can be 0 or 1. So I will explain to you what this is the significance of this end bit and what is the significance of 0 and 1 of the programmable bit after just a while, just a while. Okay. Uh, but just understand in 9-bit UART mode or mode 2 and mode 3, now instead of 10 bits, 11 bits are transmitted. 11 bits are transmitted. Okay, on this channel. Fine. Now the question arises, okay, 10 bits are stored in 8 bits are stored in SBUF. 8 bits are stored in SBUF that need to be transmitted. What about these 0 and 1? From where they will come? So they are system generated. system generated. So whenever there is a transmission and when you are operating in mode 0, bit 0 is attached to the 8 bits, precedes the 8 bits, and bit 1 is at the end of the 8 bits that is being transmitted. Okay, so these bits 0 and 1 are system generated. Fine. Now let me explain you the significance of this 1 here at the end. This is the end bit. Okay, for that, let me come to this SM2 now. SM2 bit of SCON. So I told you that definitely it is bit. That means it could either be 0 or 1. It could be 0 or 1. Okay. So 1 is for error checking. SM2 bit becomes 1 when, and this is programmable bit. That means you are going to make it 1. So when it is 1, so it is in error checking mode. So let me now explain what is error checking. Okay. So you see, whenever there is a communication between a transmitter and a receiver, do you think there may be a chances of having error being created? Yes, definitely. There is a possibility that error may be created during the course of transmission. Okay, error is not created here. Error is not created here, but during the course of transmission, it may be possible that because of some signals, stray signals, noise signals, error creep in. Okay, so there must be some provision in the microcontroller which could detect that error. Okay, so what is that provision? The provision is your this bit SM2 bit of the SCON register. Okay, so what happens? So I was talking about the stop bit. So stop bit has to be 1 always in UART communication. The start bit is 0 and stop bit is always 1. Okay. So what happens when you make SM2 equals to 1? What it is going to do? It is going to check this stop bit. Okay, it is going to check this stop bit. If it is 1, if it is 1, that means that means the chances of error is negligible or no error. Okay, and when it is 0, that means error has occurred. Error has occurred. So that so what will happen after error has occurred? So it will not now uh, uh, RI will not be set. RI will not be set. That means there won't be any interrupt in uh, in the microcontroller, and the data that has been captured in SBUF will be will remain as it is. It won't be copied and it won't go for further processing. Okay, and whenever the next data will come, that will be overwritten on SBUF register. If that again the coming data is free from error, that means the ninth or the stop bit is equal to 1. Okay, the question may arise case, say for example, the error itself is causing the 9 bit to be 1. Okay, so there are always chances of some there's no foolproof method of error checking, but definitely we can reduce that error to a large extent by doing this simple check of the stop bit. Okay, is this clear? So that means whenever the stop bit is 0 in mode 2 or mode 3, okay, sorry, mode 1 or 2 or 3, any of the three modes, that means RI will not be set and the processor will not serve the ISR. That means the data that has been received in SBUF will be not be processed, and finally it will be discarded or it will be lost. Okay. Now come to that programmable bit in UART 9-bit transmission. Okay. Uh, to explain that, let us take one example of cable connection. So, in most of your houses, you might be having that cable connection in which you are receiving various channels. Okay, and some of the channels are paid channels and some are free channels. Okay, so what happens? Say, for example, some of the subscriber or the user, they don't want to use the paid channels. Okay, they don't want to use the paid channels, but they want the free channels available for them. Okay, so what will the service provider do? Okay, you might have observed that there is a set box that is provided at from where various lines, various cables are distributed. In earlier times, this used to happen more often. These days, we directly get information on what we call direct to home channel and all those things. But in a few years back, this do happen. This used to happen. There was a box from where various there was various cables, and they go to various subscribers or various users. Okay, there was one line that was coming, and that line was carrying all the channels. Okay, and say for example, in one of the user, he do not want the paid channel. Okay, so what this uh, channel provider do, they make this bit, ninth bit, equal to 0 for that particular channel. Okay, that means now this customer who do not want the paid channel come to him won't be receiving, although it is coming here, all the channels are coming, but he won't be receiving that channel, and he will not be able to view that channel on his TV. uh, have I able to convey the concept?
Yes,
Just
sir.
see here, I told you that there is a ninth bit in 8-bit UART. This has to be 1. You cannot change it. Okay, but in 9-bit UART, this ninth bit is programmable. This is programmable. You could make it 0 or 1. So when you make it 0, that means you intentionally do not want these 8 bits to be uh, stored, or you want to basically discard these 8 bits. Okay, and if you are making them this programmable bit equal to 1, that means you want to retain these 8 bits. So that's the concept of this programmable ninth bit in 9-bit UART transmission. Okay, normally we do not normal programs that you will do, you won't use this 9-bit UART. Normally we go for this mode 1, which is an 8-bit UART. Okay, is it fine? Now remaining is your mode 1. Now mode 1 is your serial communication, synchronous serial communication of 8051, wherein the transmitter and receiver shares a common clock. Okay. So in that, since there is a common clock, you don't need these bit 0 and bit 1 to inform transmitter receiver about the bits that are being transmitted. Okay, this is the most simplest mode, mode 0, and less used mode. The most widely used mode is mode 1. Is it fine? So are we running short of time? I think time is
Yes, sir. Sir,
over,
eco class
but few
चलिए.
things I am हाँ
Yes, sir. Time more हो चुका है.
टाइम तो ओवर हो गया है. तो थोड़ा सा स्मॉल पार्ट ऑफ इट इज रिमेनिंग which is related to baud rate,
Yes.
and these TB8 and RB8, I have to explain it a bit. So I can do it in next turn. Okay,
Sure,
I
sir.
think, and then I will also be explaining one program related to serial communication so that things become more easy and
Yes, sir.
easy to.
Yes, sir. एक एग्जांपल से इजी हो जाएगा.
Okay, okay then. Thank you for joining, and I would request Sana